That's recursion. So recursion has been a very tricky concept, and so this will be the last session for computational thinking, and after this we'll be having a 1 hour session wherein you can work on these problems, and if you have any doubts you can ask us. So I'll actually do this session in a rapid fire round, so that I mean like will the main concepts that we'll cover is how to do recursion, how to I mean like define functions and print. Yeah, good level. The problem is morning session videos will take some time to be processed and put up on the portal. In the meantime, you can actually check the videos of yesterday's session, or you can listen on this session. We'll anyway be having a makeup session for all the people who missed these sessions. So we'll inform you of the date and time. That will be sometime next week, mostly on Wednesday or Thursday. So we'll let you know the date and time so that you can actually participate in this session. Okay? Okay, move on. So by the end of this session, you will be able to understand and apply recursion in CT and also call functions recursively. So recursion is nothing but calling a function repeatedly. So we'll just see a simple example of what how we used we did this example right earlier, the factorial function in we did this function example in using loops. So now let us see what exactly is a factorial function. So the other day we said that n factorial equal to n into n minus 1 and so on till 1, and this is how we did the program in loops, using loops, right? But actually if you see this function, it is nothing but n factorial is nothing but n into n minus 1 factorial. Okay, so if you can see over here, this function is again calling the same function, right? N factorial equal to n into n minus 1 factorial. So let's see, let us consider f of n is n factorial, f of n minus 1 is nothing but n minus 1 factorial. So if you can see this, this function is again being called. So let us see how to actually implement this in Raptor. So this will be our first example for today. So I'll share my screen. So I'll open Raptor. I'll first save my program. So since you already understood what functions and all are, so I won't be giving a detailed overview of what function is. So I'm just adding a procedure. I'll call that factorial, and the input is a number. So I'm just taking in the input as a number. Okay. So over here I need to read an input. Okay. So I'll say I'll ask the user to enter a number. So this number is nothing but num. Okay. So now I'll call the factorial function. I'll call factorial of num. Okay. So in the factorial method, what I'll do is I need to check if I should go on till number is equal to 1, right? I'll see if num equal to 1. If number is equal to 1, I'll come out of the loop. Otherwise, okay, I'll need to, okay, before we get on this, giving you a brief background. Factorial of 1 is 1, factorial of 0 is 1, but there's no factorial of a negative number. So what we'll need to do over here is, we'll need to check if number is greater than or equal to 1. Okay. If it is 1, if it is, okay, I'll do one thing. Instead of doing till, I'll see if it's greater than 1. Okay. So if it is greater than 1, I'll again call factorial. I'll say factorial of num minus 1. Okay. So this should do, so I am calling the factorial again. So my output, I should have an output over here. So okay, let's say the, sorry, I'll have this, I'll put the output over here. Let's say the number is less than 1. So over here what we'll say is number is less than 1. Okay. So now let us see what is happening. So if we run our code, mind you, this is not the complete code. I am just showing you how recursion actually happens. So I'll run the code in step wise. So when I say I'm going to the next step, it will ask me to enter a number. Okay. So I'm entering a number. Let's say I enter a number 5. Okay. So it's going to, it will call the function factorial with number equal to 5. Okay. So now I am in the factorial function where number is 5. Okay. Now it will check if number is greater than 1. Yes, number is greater than 1. So it's going to the function call factorial of num minus 1. Okay. So if you can see over here, again another factorial method is called, right? So in that factorial method, number is 4. So we are in the factorial method. So again it will check if number is greater than 1. Number is 4. So it is greater than 1. Again it will go to the, it will go and call another factorial method. So that, this is how, if you can see, it is calling all the numbers. It's going, I mean like it is going every time the number is greater than 1, it calls another factorial method. So it goes on like this till number is equal to 1, it's less than 1. Okay. So when number is less than 1, it's saying number is less than 1 and coming out. Okay. So if you can see, all the factorial methods are they are exiting. So now what I hope this is clear. I mean like only the function calls. Now over here what we should be doing is we should be finding the factorial. Okay. So to find the factorial, what we'll need to do is, if you let's see the output, what output we are getting. So to find the output, what we should do is we should put a statement over here. Okay, I'm running still. Okay. To put a statement over here, what we'll say is factorial equal to factorial into num. Okay. Now let's see what will happen if I put this statement over here. So before that, I'll need to assign the value of factorial. So fact equal to 1. So now let's see what will happen. Okay. Okay, this should be here. Sorry. So now let's see what will happen. Let's run it again step by step just to show you what will happen. So you are entering a number, again I am entering 5. So now factorial is 1. We are calling the function. So we will go into here. Now this, now this, now this. So if you notice, we are not getting into this statement still. We are not getting it into this statement yet. Okay. It is still, it is just going and calling this recursively, this function. So if you can see, this numbers are increasing, but we are not getting still into this statement, the fact equal to fact into num. Okay. Now number is 1. So now if you see, it is coming over here. We have come out. Now it is calling. Now we'll see the value of fact. Sorry. Oh, okay. So over here the error is I am not passing the fact. So the value of fact is not being passed over here. What I'll do is I'll just copy this and put it over here. Okay. So I'll do one thing. I'll change this. I'll say fact over here. So I'm passing two input variables. So now it should do, because I'm passing num comma fact over here. Okay. So this should work. Now let's again run our code step by step and see. So I'm really sorry for the goof ups that I'm doing. So just see. Okay, 5. So fact is 1. We are again getting into this. So now see these values. We are passing two values, 1 and 5, right? So every time we are doing, oh, I'm sorry. Again, I'll need to change it over here because we are calling the function. So comma. Okay. Running it again. So see, always factorial is 1. Always factorial is now 1. Now we'll get into this. Now see the value of fact. Fact becomes 2. Fact becomes 3. Fact becomes 4. So we are getting something wrong. I did some mistake again. Let us see. Let's change this order and see, and let's run this code. Like I said, recursion is a very tricky concept, so I'm also getting tricked. Yeah, now we can see. Now the value of fact is 20. Okay, now it is happening. So now factorial is 120. So once we are this, what we'll need to do is, so now did you observe the change over here? So once you've seen that factorial has become 20, right? So I'll run it again for you to see. So I'll just say 5 over here. So the factorial of 5 should be 120, right? So now it's getting into this loop. It's checking over here. Factorial becomes 5. We are multiplying. Again we are calling the next function. So factorial becomes 5 into 4, 20. It is again getting into the function. Again 20 into 3, 60. 60 into 2, 120. And 120 into 1. You've seen over here it is 120, right? And after that it has exited the loop. So now what we should be doing over here is displaying the output over here in the no. So let's see what will happen. What we can do is go back to our factorial method, put an output statement over here and say display fact. So over here if we do this, we should get our output. So let's say 5. So if you see, we are getting 120 as the output. So this is how we actually need to implement recursion. So I hope this is clear, and I'm really sorry for the mistakes that I've done during this explanation. So you might find using the loops was a better option instead of getting confused and confusing you all. But recursion is a very important concept, and I mean like okay, and we can actually use it to enhance the speed of our code and to get more optimized code and all. So this is how we can do this. So let's do another example. So given a positive, I hope this example was clear to everybody, right? Find factorial using recursion. Any doubts, please let me know. There might be other optimum solutions for this as well. So, but any doubt regarding the recursion example? If you have a doubt, please type it here. Otherwise, just type no, no, no. What about other colleges? Sri Chaitanya, Bapatla, Gudlavalleru, Mick. Any doubts? Siddhartha? Any doubts regarding the recursion example? The factorial one. Okay. Okay, thank you. So we'll move on to the next example. So this example is yeah. So given a positive integer n, write a program. Okay, PVP you want me to repeat it again. Okay. Okay, okay. So let's get back to our program. So I hope you've understood how a function calls itself again, the recursion part. So I'll just go. So let's do this. Yeah, okay. What we'll do is PVP. I'll put you on. I'll select you, so you can just ask your doubt. PVP Siddhartha, you can ask your doubt. Yeah, please ask your doubt. We are okay. I'll repeat it. I'll repeat the example. So coming to our example, okay. So to understand recursion better, what we'll need to do is need to run our program in the step mode. Step. So each step we'll need to go ahead and see. So first we'll need to take the input. So I'm giving the input as 5. So then we are initializing factorial to 1 because we are saying factorial for 0 or 1 is 1. Okay, and also mind you that I'm not taking any cases over here, like I'm assuming that the user will enter a positive number, positive integer value, and also that number, okay, it's not 0. So that is our assumption over here. So now let's move to the next step. So over here I am just calling a function, and that function is nothing but the factorial function, and it's taking the number as input and also the factorial. Okay, so once it calls, it gets into this function. It checks if number is greater than 1 or not. Because the number is greater than 1, it's coming over here. So fact equal to fact into num. So it now multiplies factorial. So the value of fact is 5, but number is 5. So now again it calls over here. It's again calling the factorial method. So it just see the statement. So this is highlighted still. So if you see, the control hasn't gone to end yet. So it's still calling another function. Again it comes over here. So see the value of fact. It now is 20. And now again we are over here. Again another factorial function is called. So if you can see over here, 3 factorial functions are open now, right? So in the first factorial it's calling the second. In the second factorial it's calling the third. Okay. Now we are in the third factorial function. And once again when we are here, it's calling another factorial function. So over here if you see, we are getting another factorial, right? So now we are in the fourth factorial function. So now it's done. So now it's called the fifth factorial function. So wherein we get factorial value is 120. So it's checking if number is greater than 1. It's not, so it's printing the factorial. So it's printing 120. Whereas now if you see, there are only 5 factorial methods, right? So it's print this, it will come out of this. Now it's in the fourth factorial method. So again it's in the end, this one, this one, this one. Now it comes out. All the factorial methods are closed. Now it has stopped, or the program statement control has ended. So and then we get the output 120. Is this clear? Or else we can take this up. Okay, I understand. So is this clear now? PVP, is this clear? Is the example now clear? Were you able to understand like how function calls are made, like internally? How is recursion happening? Okay, you are raising. Okay. Is there no system administrator over there, like who can control the thing? Okay, no problem. Okay, we'll move to the next example, example 2. So the example is, given a positive integer n, write a program to print the sum of the first n natural numbers using recursion. So why don't you try this problem? It's very similar to this. Instead of factorial, we'll need to find the sum. That's it. So why don't you try this example now yourself? So you will get a hang of how to do recursion. So what I'll do is I'll share my desktop. You can actually see the recursion problem and then do the same example. Over here you'll need to take the sum, but I mean, like over here we are multiplying. You just need to take the sum and print it.